Hi students, welcome to MI Academy, and today in this video we are going to continue the grade 10 chapter 3, of the science, structure of matter. Until now we have studied about matter, atoms, planetary model, and electronic configuration. And today in this video we will study about the modern periodic table. If you have not still subscribed to MI Academy, then click the subscribe button, and turn on the notification bell icon, to all, so that you can watch my upcoming videos without missing. So now you have a good idea that different elements are made up of different atoms because they have different number of subatomic particles. But there are a lot of elements in nature we need to have a way of classifying them. Therefore we will be looking at the classification of elements, that is the modern periodic table. So far they have identified about 115 elements. It's really impossible to know all the elements, the symbols, and their characteristics, even for scientists. Although they deal with elements, especially chemists, in their day-to-day activities they'll be using so many different elements. They do know the properties, but still they can't remember all the properties of all the elements. That's impossible for any person. So therefore, to identify and understand about different elements, and for our purpose to study about different elements, there should be a way of classifying these elements. The classification of elements is known as the periodic table. And over the years again scientists have attempted to classify elements in different ways, but none of those were very successful. The modern periodic table is the most successful and accepted method of classifying elements. And this was done by a Russian scientist called Dmitry Mendeleev. And in this periodic table he arranged the atoms in ascending order of atomic number. So he uses atomic number for his classification and arranges the elements in ascending order of atomic number, and also he considers the electronic configuration. We have discussed these two by now. You all know with very well how to write electronic configuration for elements. Now I will just show you all a basic structure of a periodic table. This is a very simple form of periodic table that you will be using for your level. And in this periodic table you will notice that there are certain patterns and similarities. If you look at elements when you arrange it in ascending order of atomic number, some elements will fall into a certain group. We can say similarities, and also you will see there will be a certain trend or a pattern in this periodic table. So, one purpose is to classify elements, arrange them in order, so you can compare the properties and identify elements very easily. And also it is easy to study about elements as well. Now we will look at the proper arrangement of a periodic table. In this you can see there are different colors given for different elements. Here as you can see the elements in the periodic table is colored in blue, because these elements show metallic character. We call them metals, whereas the light brown color region are non-metals. The dark brown region is the noble gases. And you can see there is a zigzag step-like pattern there. These are shown in green color and they are known as metalloids. We will be discussing these types and their properties later in the lesson. Now we will look at the nature of the periodic table, and these are the elements that have been identified so far. And here we have the numbers 1, 2, 3, 4, 5, 6, 7, 8 or 0. We will call them as the groups. You might be wondering why the two groups are here, and the rest of the 6 groups are on this side, and there is a space here. Yes, the reason is we need to have only the metals here. Now boron is a metalloid. So if we put boron here the properties will not show a proper pattern. That is the reason it has been pushed to this side. And again here there are a lot of elements which we will not be looking at. But they are also metals, so now you have a good understanding, a basic understanding about the periodic table. This is the full periodic table, and out of this periodic table, we will only look at the first 20 elements. So then as you can see here, this is a part of the modern periodic table, and here we only have this part with the first 20 element. And the space between this beryllium and boron and all the elements there have been taken out. Only these 20 elements are shown in this. In the groups, as you can see, they are given the Roman numbers. Then we have the horizontal rows. These are known as the periods. And periods are numbered as 1, 2, 3, 4. So all the elements in group 1, except hydrogen, lithium, sodium, potassium will have similar properties. Beryllium, magnesium, calcium will have similar properties. Fluorine and chlorine will show similar properties. And group 8 or group 0, helium, neon, argon will have similar properties. Now we will see how we can arrange these elements into different groups and periods. First, we will see how we can divide elements into periods. If we take an example, you look at the simple part of the periodic table. If we take hydrogen, hydrogen is an element that has only one electron. So the electronic configuration is 1. Helium is another element that has 2 electrons. The electronic configuration is 2. So the electronic configuration is 2 and 1. Here you can see the first 2 elements, hydrogen and helium, have electrons. Only in their first energy level. The first energy level can accommodate a maximum of 2 electrons. And hydrogen has 1. Helium has 2. So these 2 elements belong to the first period of the periodic table. So that means if an element has only the first energy level carries electrons, then those elements go to period 1. Then lithium. Lithium 3. So 2 electrons in first period and 1 electron in second period. Starting from lithium up to neon, atomic number 3 to 10. They will have electrons in the first and the second energy level. And these elements belong to the second period of the periodic table. Likewise, we take elements from atomic numbers starting from 11 to 18, starting from sodium up to argon, atomic numbers 11 to 18. They have electrons in the first, second and third energy levels. Only the first, second and third energy levels carry electrons. So that means they all belong to period 3. Now we will look at the last 2 elements, potassium and calcium. So as you can see, the atomic number of potassium is 19. When we write the electronic configuration, it's going to be 2881. We have to write 8th electron in the third period, and the next one will go to the 4th energy level. You can see, students, in these 2 elements electrons are present in the first 4 energy levels. So therefore they come in the 4th period of the periodic table. As you can see, only the first, second, third and 4th energy levels carry electrons, then they go to period 4. Now you might be wondering why we say only the first, second, third and 4th. But we are only looking at the first 20 elements. So we are using only the first 4 energy levels, but there are more than 4 energy levels. Now you have understood how the elements are arranged into different periods depending on the number of energy levels that contain electrons. We can say period to which an element belongs to is equal to the number of shells that contain electrons. That is the relationship between the period number and the number of shells, and that is how we arrange elements into periods. Next we will see how elements are grouped into groups. Dividing elements into groups. The properties of an element depends on the number of electrons present in its outermost energy level. You saw that these elements, for example lithium to neon, they are in the second period of the periodic table. That means they have electrons in the first and the second energy levels. The difference is they have different number of electrons in the second energy level. Lithium 1. Beryllium 2. Likewise, when we go to neon, it had 8 electrons in its second energy level. Same for the elements of the third period. They had 3 energy levels that have electrons, but the number of electrons in the third energy level varied from 1 to 8. So because of that, the number of electrons present in the outermost energy level is given a special name, valence electrons. Now we can better say outermost energy level containing valence electrons is known as valence shell. So here you can see valence shell having only 1 electron will go to group 1 in the periodic table. If you look at all the other elements in that group, sodium atomic number 11. So electronic configuration is 281. Valence electron is 1. Potassium atomic number 19. Electronic configuration 2. 881. again 1 electron. So all these 3 elements go to group 1. So we'll look at some other elements. Carbon and silicon. Carbon has atomic number 6. So the electronic configuration is 2, 4. 4 electrons in the valence shell. So it belongs to group 4. Similarly, we take silicon has atomic number 14. 284. That also has 4 electrons in the valence shell. So this goes to group 4. Same way we take the elements helium, neon and argon. Helium has only 2 electrons. Neon, the atomic number is 10. So the electronic configuration is 28. And argon atomic number is 18, so it's 288. Here you can see, these two have 8 electrons. So therefore they go to group 8. But helium has only 2 electrons. It also goes to group 8. The reason is having a full energy level. That is an energy level with maximum number of electrons. So it's a stable electronic configuration. So therefore any element here with a stable electronic configuration also goes to group 8. Here you can see, if the element has only 1 electron it belongs to group 1. Element has 2 electrons, it's group 2. 3 electrons, group 3. 4 electrons in the outermost energy level, group 4. 5 electrons in the valence shell, group 5. Valence electrons are the number of electrons in the outermost energy level. Then valence electron 6 belongs to group 6. 7 electrons in the valence shell, group 7. And 8 electrons in the outermost energy level, then the element belongs to group 8 or group 0. So now we have arranged or divided the first 20 elements into periods and groups. We will see how we can identify the position of an element in a periodic table. So for example, if they give you the atomic number of an element. So the atomic number of magnesium is 12. That means there are 12 protons, which is equal to the number of electrons. So there are 12 electrons in an atom of magnesium. We will now distribute these electrons into their energy levels. The first 2 electrons will go to the first energy level, that is the K shell. Then 8 more electrons can go into the second energy level. That is the L shell. There are 2 more electrons. They will go into the last energy level, or what we call as valence shell. So if we write the electronic configuration 282, so number of shells that contain electrons is equal to period. So here it is period 3. So how do we identify the group number? The number of valence electrons. Magnesium has 2 valence electrons. So it has to belong to group 2. So magnesium is present in period 3 and group 2. We will look at another example. Atomic number of potassium is 19. So then we can write the electronic configuration 2881. How do we identify the position? The number of energy levels carrying electrons in a potassium atom is 4. Therefore it is an element in period 4. What is the group? A potassium atom has 1 electron in its outer energy level. Therefore it belongs to group I. Thus potassium is found in group I in period 4 of the periodic table. So students, now you have a very good understanding about identifying the position of elements in the periodic table. And by now you should have memorized the correct order of the first 20 elements. And you should know to write the electronic configuration. Using these two you should be able to identify or find the period of the element and the group of the element. So if we summarize the periodic table, it is based on atomic number and electronic configuration. Elements are arranged in the increasing order of atomic number. And the number of shells that contain electrons in a particular element will be equal to the period number. And also the number of electrons in the outermost energy level will be equal to the group number of that element. And we have come to the end of our video. So please give a support to us by subscribing to MI Academy, and also please like my videos, and add up your questions and doubts in the comments. I will try to reply them as soon as possible. Share the videos with your friends, and help them to learn quickly and easily.